everyone. Today I want to continue the lesson semiconductor diodes again. There's a part 2. Okay, let's see the part 2. Okay, remember I asked you one of the questions that's about the germanium and silicon. They got the volt is 0.3 and 0.7. Then I asked you what situation then we cannot pass through the junction, the PN junction, or you say depletion layer. Okay, so today I want to explain why although there are smaller voltage, but the electron still cannot pass through. Okay, let's go and see the forward bias first. Okay, let's see the forward bias. Okay, can you see first part? The N-type semiconductor, they join with the terminal negative. They join with the terminal negative. Okay, then the P-type, they join with terminal positive. So that means the connection should be correct. Okay, now that means when your terminal you join with the correct, so that means now the electron and also the hole, they are easy to be drift. Drift from where? From the depletion layer. They're easy to move from the electron, go to fill in the hole. Okay, for this one situation, we call it forward bias. Forward bias means the connection should be correct. After that, the electron can be drift, then can conduct electricity. So from here, let's see the circuit. Okay, the circuit is here. Okay, when you see the positive, they join with the anode, then the negative join with the cathode. So that means now the current can go through. Now the current is go through in one direction. So you find it the bulb should be light up. So this one situation we call forward bias. So this one question can come up from 4 marks question. They just ask you, how come the bulb can be light up? Please explain the process. So from here, we got at least got 4 points to answer this question. Okay, let's see the explanation for the forward bias. Okay, first one is a connection. We are talking about a connection. P-type of the semiconductor diode must be connected to the positive terminal. Okay, join with positive terminal. And the N-type must be connected to the negative terminal of the battery. So this one is a connection should be correct. Okay, B. Then we're talking about the voltage. Okay, when your connection should be correct, that means the voltage can be passed through. Now the cell voltage greater than the junction voltage. So you must mention this one because you're using the battery at least 1.5 volt. So that means 1.5 volt, although you're using the silicon or you're using the germanium, the voltage for the circuit must be higher than the silicon. So that means now junction voltage, you are over the voltage already, that means you can pass through. So B, you must mention now the voltage from the battery is greater than the junction voltage. Okay, C, now you must say the layer become narrow. Okay, you can pass through means the layer become narrow and the resistance of the diode decreases. Resistance decreases means the current easy to pass through. Okay, last one, a large current flow through the diodes and the bulb is light up. So this one is a 4 marks, how we explain the forward bias. Okay, this one is what I want to explain, reverse bias. Okay, for this part, can you see the center part? There's a depletion layer. They become wider. When they become wider, the meaning is electron and also the hole, they are pulled back each other. That means they pull far away from each other, means the current cannot go through. Okay, from this part, what's the problem? Okay, the problem is, can you see the terminal connection? Positive type, they join with the negative terminal. Then the N-type, they join with positive terminal. Means the connection is wrong. When the connection is wrong, means the voltage cannot go through there. The voltage cannot produce. The voltage cannot produce means we can say there's a zero voltage. Zero voltage means now you are less than the depletion layer, the junction voltage. So this one is the reason why I say, although germanium and silicon, the voltage is lower, but you still cannot go through. So that means you cannot over the junction voltage. So from this part, we find it, the bulb cannot light up because your connection is reverse. Okay, let's see the explanation for reverse bias. Okay, 4 marks again. First one, we're talking about the terminal connection. Okay, first one, the N-type of the diode is connected to the positive terminal. Then the P-type, you join with the negative terminal. So from here, you find it, the cell voltage now is lower than the junction voltage. So from here, depletion layer will become wider, and the resistance of the diode become increases. Resistance increases means the current cannot go through. So from here, they say no current flow through the diodes and the bulb does not light up. So this one is a citation for reverse bias. Okay, now we go and see the diode, another function. Okay, the diode also as a rectifier. We see what means of rectifier. Okay, a diode can act as a rectifier because they can convert alternating current to direct current. So rectifier means they convert the AC become DC. So the process when we convert AC to DC, we call it rectification. Okay, now you can see the diagram. Diode, the function is rectification, means they convert the anode. From the anode, there's an AC to go in. When the cathode to come out, that one is a direct current. So from here, we got two types of the rectification. One is a half-wave rectification, another one is a full wave. Okay, half-wave, that means you just convert halfway only. Okay, full, that means when they just come and second round they come, they will also go to convert. So we got half-wave and also we got full wave to convert alternating current to direct current. So that means don't care full wave or half-wave, we must using diode, because the function for diode is rectification. Okay, we start with the half-wave. Okay, let's see half-wave rectification. Rectification is a process to convert the alternating current to direct current by using the diodes. Okay, let's see the diagram. Okay, can you see the first one, input? This one is an alternating current. Okay, up and down, up and down. Okay, now we start the current, how to flow first. So the first one, they say current only flow in the first half cycle. Why the current only flow in the first half cycle? Let's see here. First part, we start with A. Example here is start with positive. So we go A. Okay, after we'll go to B. Okay, when they go to B, this one is a cathode. Okay, this one is an anode. Anode is okay, there's a positive. This one is a forward bias. So that means the current can go through the B, after that go to C. Okay, from here we join with the CRO. CRO means cathode ray oscilloscope. Later we show the display of the wave. Okay, after that they pass to the R. Okay, R is a resistor. So we draw here. When they pass through to the R, we find it the direction. Okay, the direction is go down. Okay, pass through R. After that, go to the D. Okay, after that, go to the E. So that means one complete of the circuit current how to flow must be from starting from A, must ending from the E. We cannot say start from A, end from A. That one not complete. Must start from A, end from E. Then we say complete. Okay, now this one is a first half cycle. So we say this one is a first half cycle when the diode there's a forward bias. Okay, let's see the second half. Second half means you start from E already. Okay, when you start from E, that means I take the E is a positive terminal. Okay, now they start from E, then go to the D. Okay, when they go to the C, now the current is opposite already. Now the current is go up. Okay, second cycle, the current is up to the C. Okay, when they up to the C, they face the diode. So now the diode, this part is a cathode. Cathode is a negative. So that means the positive, they cannot go through the negative. So that means now the diode is blocking the current go through, because the diode just let the current flow in one way direction. So from this one situation, we find it, the second half cycle is not success. So that means you see the output. Okay, the output here, there's a nothing. Okay, second cycle, there's a nothing. Don't have any volt. So means the second cycle, there already is a reverse bias. So from here, the second one they explain, the current is blocked in the second half cycle when the diode is in reverse bias. So from here, this all situation, we call it as a half wave. Okay, you see the result output, that one is a half wave. So that means you just can read for the first cycle only. Second cycle you cannot read. Then the third cycle you can read. Number 4 you cannot read. So this one is convert half wave only. Okay, so this one is the first one, half wave rectification. Okay, one more thing I want to explain. The output, can you see the output is AC or DC? Should be DC. Can you see all the reading is above the horizontal line? Above the horizontal line means there's a positive part. So that one is just one type of the current. There's a direct current. So input is a AC because they got up positive, then they got down negative. So this one is an alternating current. After pass through the diode, they produce direct current. So the whole process we call it as a rectification. Okay, but this one, when you want more detail, we call it half-wave rectification. Okay, let's see this part. This part is a half-wave rectification, the example. Can you see the current just go through in one-way direction? They pass through positive, then go negative, then they come back. So from here, the alternating current from the input, when the output they produce is a direct current. Okay, now we need to go is a full wave rectification. Okay, full wave rectification we using is diodes, also diode, but we got 4. Okay, 4 diode arrangement like the diamond shape. So this one we call it bridge rectifier. Okay, how we draw it? The A and D, A and C, the shape for the diode must be the same. B and D, the shape become the same. So make sure the arrangement you draw must be correct. Okay, now we need to explain how to convert the full wave cycle. Okay, first one, alternating current input. Okay, now we go through to the first cycle. There's a red color arrow. Okay, we start from P. So the P is up. The current go up. Then until this junction. Okay, they must go to forward bias. So they must find the B. Okay, diode B. After that, until this junction, we cannot go through the C because C is a reverse bias. So we continue to this part. Then we go down. Go down to resistance and also go to CRO. Means now when I pass through the CRO, that means the cathode ray oscilloscope can read the reading of the current. Okay, when I pass through the resistance, I go downwards. When I go to the R, I go downwards. Okay, then I continue. Okay, until this part, I want you to see this part. This part is a 2-wire overlap. Overlap only, they never join together. So when the red color wire, they go through, they just go straight. After that, they up. Okay, until this junction, they cannot go to the A. When they go to the A means they go back to the original position. That's a wrong. So until this one junction, we must go through another terminal. There's a D. Okay, after go to the D, then I continue the red color arrow, then I go back to the Q. So from here, the first cycle, the path of the current, how to go through, they flow from the P to the B. After that, go to resistance, then go to the D, and last one, go back to the Q. So that means this one is a complete cycle. So I can draw about the direct current for the output. So this one is the first cycle, direct current. Okay, now I need to go is a second cycle. Second cycle, there's a blue color. Okay, let's see the blue color arrow how to start. Okay, we start from the Q. Start from the Q. After that, the Q must be here. Okay, now continue until the junction. Okay, I cannot go through the D because D is a reverse bias. I must go to the C. Okay, when I go to the C, I also cannot up to the B because B is a reverse bias, so I continue. So when I go through the resistance, where I go downwards. Can you see I always go downwards the resistance? I also always goes downwards to the CRO. So that means CRO later, they show the reading is always downwards. Always downwards means one direction. One direction means direct current. Okay, so that means the CRO later they show the reading is in one direction only, because I pass through a resistance and CRO always go downwards. So they just got one type of the current, there's a direct current. Okay, after I pass the resistance, the blue arrow, I continue to go here. So this one overlap, I go straight, I go up until this junction. So this junction I cannot go to D. If I go to D, I go back again. So I must go to opposite terminal. Then I go through the A, then up, then I go back to the P. So this one we call second full cycle. So now let's see the second cycle, how to go through. From the Q, go to the C. After C must resistance, then go to the A and go to the P. Mean second half cycle also complete. So that means I can draw the output second half cycle, got another reading. So that means I continue the situation. First cycle, second cycle, third cycle, and fourth cycle. So finally, I can draw my output graph. The output graph is always the voltage is above the horizontal line. So that means from alternating current, I can produce a direct current. And also this one is a produce full wave current. Just now is a half wave. This one is a full wave. So if the question asks how to produce the full wave rectification, so your answer is you must create, or you must build the component of the diode become 4. Then also this diamond shape, we call it as a bridge rectifier. Okay, then you must draw. After draw, you must draw the arrow. Okay, label the arrow, let the current how to flow. Okay, so this one is a example for the bridge rectifier lah. So from here, the label I show here first. Okay, let's see the blue and also the green arrow. Okay, let's see, we start with the first cycle. That's blue color first. Okay, blue color, they start to flow from the upper part. Then go through to the resistance. They want to go back. Okay, then they pass through the another diode, then go back. Okay, now we go to the green color part, second half cycle. Okay, second half cycle means they go through another terminal, they come out. Then they're using different of the diodes. Okay, then they pass through the resistance. I just want you to see the resistance part. Can you see both arrow is the same direction? Both arrow is the same direction means later I read the reading from the CRO, there is a direct current. Okay, then the green color, go back to the original part. So from here we can say there's a two-way direction. First is a blue color, another one is a green color. From the two-way, from the terminal and positive and negative. But when they go through resistance, just one-way direction only. Okay, so the last part from this topic, there's a capacitor. We see what's the function for capacitor. Okay, first one, when the current they pass through the resistor and also the capacitor. So capacitor function is what? They go to charge. Capacitor will receive the charge. After that, store energy. So that means they can store the charge in the capacitor. When there's a no current, what situation there's a no current? There's a reverse bias. When there's a no current pass through the resistor and the capacitor. So the capacitor, they will discharge. What means discharge? That means they will release the charge. Okay, release the charge to the circuit. So the energy from it is used to produce the voltage across the resistor. So the discharge means they release the voltage to pass through the whole circuit. That means the whole circuit got voltage. So now as a result, they produce a smooth direct current output. So that means although it's a reverse bias, when you put the capacitor, they still can produce the current go through the circuit. Okay, so this one is a function for capacitor. So they make the whole circuit become more smooth. Then they produce the output. You can see the graph. There is a difference from the original. So this one is the graph. Okay, when I just put the capacitor, okay, one more thing you need to know, the capacitor must put in parallel. Okay, we put as a parallel with the resistance. We cannot put as a series. So from here, the capacitor you put at the parallel. So if when starting is without capacitor, you find it. This one is a halfway cycle. When I just put capacitor, okay, you need to draw sliding line. Okay, after you draw the sliding line, then the middle one you go to cancel, then the finally become like this. So when you see like this, means the current, they are more smoothing when they just produce. So this one is another situation. Alternating current after pass through the diodes, they got capacitor. So you find it, you must draw the sliding line to another cycle. Okay, so this one is when I use the capacitor, what's the function? They make the output circuit is more smooth. Okay, this one also same. This one they're using the full wave rectifier. They're still using the capacitor. Okay, they're using capacitor. So if without the capacitor, the wave should be like this. Full wave rectifier. Okay, when I just using the capacitor, you find it. The center part. When the center part up want to go down, the straightforward cancel, they become sliding. So you can see this part, the voltage is always high. Okay, always higher. So this one is part 2 for the 4.2 semiconductor. So that means you can continue the tutorial. There's a 4.2. So the next lesson